Okay, fourth reaction is the sulfonation reaction. Sulfonation reaction. In this reaction, when benzene reacts with the fuming sulfuric acid, that is a mixture of sulfuric acid and sulfur trioxide, it gives rise to benzene sulfonic acid. Okay, so in benzene, one hydrogen will get replaced with the SO3H group. So let us see this reaction. When benzene will react with H2SO4 sulfur trioxide at room temperature 30 minutes. So we will get this. This is the benzene sulfonic acid. So one hydrogen will get replaced with this SO3H group. When benzene reacts with the fuming sulfuric acid, a mixture of SO3 and H2SO4 at room temperature, and within 30 minutes we would get this benzene sulfuric acid as a product. So let us see its mechanism. Its mechanism involves the four steps. In the first step, step 1, it generates this sulfuric acid generates the electrophilic SO3. Okay, this H2SO4 will generate electrophilic SO3. Okay, this is the electrophile. So in the second step, this benzene will get attacked by this electrophile SO3. Okay, so we will get this complex SO3. It will act as a negative charge, and we can show here hydrogen. Okay, so we will get this complex. Then in third step, step 3, this proton get eliminated. Okay, since we have this conjugated base HSO4 negative, so in third step, we have this HSO4 negative. Okay, so this proton get eliminated. So we would get this SO3 negative. Okay, this is the fast step. And earlier one is slow. step. Okay. So we would get this product in the first step. Here I will write step 4. Step 4. So this will react with acid, for example H3O. So we would get benzene sulfonic acid as a product plus H2O. Okay, so this is the step 4. So this is how this reaction will undergo. In the first step, this H2SO4 will generate the electrophilic SO3, and in the second step, this SO3 will attack on this benzene ring to get this complex, and in third step, so that proton will get eliminated. Okay, so to give this SO3 this product, and in the final step, that means in the fourth step, this will acquire the proton, so it will end up with this benzene sulfonic acid. So this is how this sulfonation reaction is. So next reaction is Friedel-Craft alkylation and acylation. Okay, next reaction is the Friedel-Craft alkylation and Friedel-Craft acylation. So let us see the first Friedel-Craft alkylation. Okay. Friedel-Craft alkylation is the electrophilic substitution reaction, and it is the easiest way to introduce alkyl group into the benzene. So when benzene reacted with the alkyl halide in the presence of Lewis acid, okay, so it gives rise to alkyl benzene. So let us see the general reaction when this benzene reacts with alkyl halide in the presence of Lewis acid. It gives alkyl benzene, okay, along with the acid. Okay, so when benzene reacts with methyl iodide in the presence of AlCl3 as a Lewis acid, which gives rise to methyl benzene. This is toluene. Okay, plus HR. So similarly, so Friedel-Craft acylation can also be done in the presence of Lewis acid. Similarly, Friedel-Craft acylation. Friedel-Craft acylation. When benzene can react with acid chloride in the presence of Lewis acid, for example, aluminum trichloride, which gives rise to phenol, acetophenol as a product. So there are various acylating reagents can be used. So in this reaction, the effective electrophile is acylium ion, okay, which can be generated from acid chloride. Okay, this is the acid chloride. Then we can generate it from acetic anhydride, or even we can generate it from acetic acid. So in AlCl3 we can generate this acylium ion. Here AlCl3 we can generate this acylium ion, and here in the presence of H2SO4 or simply I will write H plus, so we can generate this acylium ion. Okay, so in this reaction the effective electrophile is acylium ion, so which can be generated from various methods. For example, from acid chloride we can generate, from acetic anhydride we can generate it also, and even we can generate it from acetic acid with the help of H plus. So in this way we can generate this acylium ion. So important features of these two Friedel-Craft alkylation and acylation is, so we can introduce the alkyl group, more than one alkyl group to benzene ring. Okay, so but when you acylate the benzene ring, so second acylation will not occur. Okay, so okay. So let us see. So let us see the important features of the acylation, Friedel-Craft acylations. Important features of acylation. Okay. As we have seen the Friedel-Craft alkylations, so we can introduce the alkyl group. Okay. So when you introduce the alkyl group, the benzene ring will get activated. Okay. So second alkylation will occur. Okay, but on the other hand, when you introduce the acyl group into the benzene ring in the presence of AlCl3, so which gives rise to this product. So when you introduce this acetyl group into this benzene, so this benzene will get deactivated. Okay. So this benzene ring will get deactivated. It becomes deactivated ring. So second Friedel-Craft acylation will not occur. Okay, but in the Friedel-Craft acylation, alkylation, sorry, this become activated ring. So this ring will get activated and polyalkylation will takes place. Okay, because this ring will get activated. On the other hand, in this reaction, so because of this acetyl group, this ring gets deactivated. So second Friedel-Craft acylation will not occur. Okay. So this is the one of the important feature of this acylation. So by using this Friedel-Craft acylation, we can introduce the long chain of the alkyl group. Okay. So in this acylation, like Friedel-Craft alkylation, there is no possibility of rearrangement. And other important feature is, so we can introduce the long chain of the alkyl group. Okay. For example, when benzene reacts with this acetyl chloride, Friedel-Craft acylation, so which gives rise to the acylated product like this, CH-3. Okay. So here there is no possibility of rearrangement. So because we have this carbonyl group, so it will get directly attached. Then in the second step, zinc amalgam HCl, that is Clemmensen reaction. Clemmensen reduction would give the reduced product. Okay. So this Clemmensen reduction, zinc amalgam in the presence of HCl will reduce this carbonyl group to give this methylene group. Okay. So as to make it long chain. Okay. So this is one of the important features of the acylation reaction. So we can introduce the long chain of the alkyl group into the benzene. So this is not possible in the alkylation because there will have the rearrangement. Alright. So this is how the electrophilic substitution reactions. So we have seen the various electrophilic substitution reactions. First of all, we have seen the nitration of the benzene, where the nitrogen mixture, that is nitric acid in the presence of H2SO4 will react with the benzene to give the nitrobenzene. In the second reaction, that is halogenation reaction, benzene will react with the halogen in the presence of Lewis acid. 3 halogen cannot undergo this substitution, electrophilic substitution reaction. Okay. In the third reaction, that is sulfonation, sulfonation of the benzene will occur in the presence of fuming sulfuric acid. Okay, so fuming sulfuric acid will react with the benzene to give the benzene sulfonic acid. One hydrogen will get replaced with the sulfonic SO3H group. Okay, so that reaction will involve the 4-step reaction mechanism. Okay, and this last electrophilic substitution reaction, that is the Friedel-Craft alkylation and acylation. Okay, so we are seeing the Friedel-Craft alkylation. So there we can generate the alkyl carbocation. So it is having the similar mechanism as the electrophilic substitution reaction. Then we are seeing the Friedel-Craft acylation. So there are various reagents available to generate acylium ion, that is the effective electrophile in this particular acylation reactions. And along with this, we are seeing the important features of the acylation reactions. Okay, so in the Friedel-Craft alkylation, when we introduce the methyl group into the benzene ring, so that ring gets activated. Okay, so because of that activation, further polyalkylation will occur. On the other hand, when we introduce the acyl group into the ring, that benzene ring will get deactivated. Okay, and because of that deactivation, further Friedel-Craft acylation will not take place. Okay, so this is one of the most important features of the acylation reaction. And like Friedel-Craft alkylation, this rearrangement of the carbocation will not occur, because this acylium ion will directly approach to the benzene ring. Okay, and next one is we can introduce the long alkyl chain into the benzene ring. In this reaction, we are seeing when benzene reacts with this acetic chloride, this acetic chloride is having the long chain of this alkyl group, so we can introduce to give this acetyl product, okay, this ketone, and in the next step, we can reduce this carbonyl group with the help of this Clemmensen reduction to give this reduced products, so as to get this long chain in the benzene ring. So in this way, we can introduce the long chain of the alkyl group. So this is how these electrophilic substitution reactions are. So I hope you enjoyed this session and understood as well. So in the next lecture, we will see the various benzene derivatives. We will see the side chain oxidation of the various benzene derivatives by using CHEM